In this short video, I'm gonna show you how to use Abaqus to build and analyze a reinforced concrete column. This is a Word file showing us some parameters and material properties. In the Abaqus, we need to define our own units. So in this example, we are going to use millimeter as the unit of length, kilogram as the mass unit, and Newton as the force unit. And we'll keep the units uniform all throughout the process. So now let's start. We are going to use this logical order to build and analyze. The first part module, we are going to create 3 different parts. The first is the concrete. We are going to use 3D deformable solid extrusion. For the approximate size, let's check the file. It's 300 times 300. So for me, I would like to use twice. So I'll type 600. Here we have a lot of options to construct the model. So in this part, I want to use the rectangular one. Starting point 0, 0. The opposite end. Here I just enter the coordinate. Type 300, 300. Click enter. I got the square. Click done. The depth. We know the length of the concrete is 2000. So we just tap 2000. So now we get the concrete part. The next, let's create the part of the main rebars. Here we use wear planar. For the size, we know the dimension is, the length is 2000, so I use twice 4000. I use the line order from the origin to I enter the coordinate 2000, 0. Click done. The next part is the stirrup. Likewise, we are going to use wear planar. For the size, I type 480. Here I use the line order from the origin. The next point 240, 0, enter. Next 240, 240, enter, 0, 240, enter, and back to the origin. And this is the stirrup part. So now we can see we have successfully created the 3 different parts. The next, property module. In the property module, we are gonna create materials and sections. The material, we need to create 2 types of materials in this example, steel and concrete. So for the first, let's start from steel. From general, we type in the density. Make sure the units we use are correct. From mechanical elasticity, we input the elastic modulus. For the plasticity, we just input these values. Now let's create the material of concrete. Likewise, general density. Elastic properties. For the plasticity, we need to select the concrete damage plasticity. Just input these values. For the compressive behavior, we just select all the values in the file and then do the copy and paste. And do the same thing for the tensile behavior. Select all, copy and paste. So we have created the two materials. The next, we can create sections. Here we have 3 different sections. So the first section, concrete. We make it solid, homogeneous. Select the material, concrete. OK. And create the section of the main bars. Here we use beam truss. Material, steel. Cross-sectional area. Let's check the file. Just input this number. Next, the section of stirrup. Likewise, beam truss. Steel. Also, just input this number for the cross-sectional area. So we have set up 3 different sections. Now we need to assign these sections to the parts. First, stirrup. And I want to make a set here, so just uncheck. Select the region. Make it stirrup. So the color has changed, which means it is successful. So the next, the main bars. Assign section. Select the region, then the bars. So next, concrete. Select concrete, then concrete, OK. So the color has changed. So now we can go to the assembly module. Click Create Instances. Click the concrete, it shows here. Click OK. Now we add the bar. You will see the bar shows here. We need to rotate and translate so that it can be put in the correct position, the same as the one we see from the example. And also in the file, it shows us the point coordinates. So here, let's do something. From the tab Tools, Data, Point, Enter Coordinate. So let's just input these 8 points, the 8 coordinates of the points. So for the first one, click enter, you will see the point shows up in the section. This can help us easily move the bar to the correct position. So now let's just input all this data. Okay, so now we have 8 points. Now we can click Create Instance. Select the bar, click OK. First we need to rotate. Click Rotate Instance. Select the instance. So for the starting point, we need to rotate it around y-axis. So the starting point, we can make it a region. For the second, we can make y equal 1. So this means this one will rotate around y-axis. Rotation angle 90, OK. Click OK. So now the bar has been rotated. Now let's click Translate. Select the instance. Then starting point, the origin. Enter. Select the endpoint. So we can click the point we just input. So you can see this makes it easier for us to move the bar to its correct position. And here we can click the icon and we can adjust the percentage of the transparency so we can see the steel bar within the concrete. So let's do exactly the same thing for the other 7 main bars. Okay, so now we have added all the main bars. So click Create Instance, we add the stirrup. So you will see the stirrup is showing up right there. So we need to translate to the correct position. From the file, we know the point coordinate for the first stirrup. So we're going to use this coordinate. Let's click Translate Instance. Rotate it a little bit. Select the instance, which is the stirrup. Click Done. Starting point, the origin is OK. Click Enter. The end. So we just type the coordinate 30, 30, 1950. Click Enter. So you will see the stirrup has been translated to its correct position. Now we're going to use the linear pattern to copy the stirrups, so it can be put along z-axis. Click the linear pattern, select the instance. It's a little bit difficult here, so I select all at first, and then I keep pressing Ctrl, select the concrete and the main bars to make sure only the stirrup is selected. Click Done. We only want to copy the stirrup in z-axis, so we need to do something. This is the direction, so we can select either line in z-axis. So now we can see it can only copy in z-axis. Let's make the offset 190. Change the number to 11. So now we have assembled the whole parts together into one model. Now we can go to the step module. In the example, we need to add 2 loads. So let's add 2 steps here. Step 1, right after initial, static general. Make it on, because this is for the nonlinear analysis. Make it from point 0.01 to 0.1. Click OK. Let's add another step. Make all the same, make it on from point 0.01 to 0.1. Here we also have the field output and history output, but I'll do this part later. Now we can go to the interaction part. Click Create Constraint. We are going to use the embedded. Click Continue. Select region. For this, we're gonna select all the main bars and stirrups. So we select all, keep pressing Ctrl, select the concrete. Click Done. Click Select Region. This time, we're gonna select the concrete as the host, so it turns pink. Click Done, keep all this, click OK. So now we have finished the interaction module. The next load module, we're going to create load and boundary conditions. For the boundary condition, one free, one fixed. Let's make the left one fixed. So click Create Boundary Conditions. Make it at initial step. Displacement, rotation, continue, select the region. Let's select the section. Since it's fixed, so let's just check all these boxes. OK. For the load, the first load is the axial load, pressure, compression. So click Load, add step 1, mechanical, pressure, continue, select the region. So this load is added in the free end. So let's select the free end section. Here we have different options. So I'm going to use uniform. So the magnitude should be with the unit of Newton per square millimeter. So we need to do something here. We use 270 kilonewton over the area, 300 times 300 square millimeter. So the value should be 3 Newton per square millimeter. In Abaqus, we only type in the number. So we just input 3. Positive means the direction is towards the section. So you can see we have added the axial load. The lateral load is in the form of displacement of 200 millimeter. So we add it in the boundary condition in step number 2. Likewise, displacement. Select the region. We select the free end. We check U2 and input the number -200. So this lateral load is added in the form of a displacement. So we have finished the load module. We can go to the mesh part, the mesh module here. We need to mesh by parts. Because we have 3 parts, so we need to mesh 3 times. The first, concrete. We can change the number. So here I'm going to use 40. Click apply. OK. Mesh the part. Yes. So you will see the small cubes here, which means we have successfully meshed the concrete part. So the next, the bars. Before this, let's do the element type. Keep scrolling down. Select the truss. Seed edges. Select the whole part. Done. Change the number to 40. You can use other values to try. Mesh the parts, yes, and the color has changed. The last one, stirrup. Likewise, select element type. Select the whole region. Truss. Seed edges. Select the whole region. I use 40. OK. Mesh the part. Yes. The color has changed. So we have finished the mesh module. We can go to the job. But in this question, we need to plot the load displacement curve. So we need to deal with some data. So let's do something to store the data during the analysis. Let's go to the step module. We're going to use the create history output. But before doing this, let's make 2 sets. From the Tools tab, go to Set, Create. For the load displacement curve, I'm going to use the reaction force in the fixed end and the displacement at the free end in y direction. So for the first set, I use RF2, reaction force in y direction. I select the region, I select the fixed end, click Done. And the second, I'm gonna use 2 nodes as the set to record the displacement. I name it U2, select nodes. I select the 2 nodes in the free end. Click Done. Later I'll show you how I can use these 2 sets. So create history output. I name the first one RF2. I want to record the reaction force in y direction. For the set, I use RF2. I only select the force RF2. click OK. The second history output, U2, continue, but here I only record the data of displacement in Y direction, so I check the box of U2. Click OK. So I have finished creating the history outputs. We can go to the job module, create a new job, give it a name, and now we can click Submit. We can see the job has been created, and we can click Monitor to see the process. It's okay if you see the mark right in front of the warnings. If there is a mark in front of the errors, the analysis will be aborted. This means that something is wrong with our model, so we need to go back and recheck. Since we consider the nonlinear analysis, so it takes time for the Abaqus to calculate. Let's just wait for a while. So the example has completed successfully, which is great. So we can click Results. S here means stress. We are more interested in the reaction force, so let's select in Y direction, RF2. This shows the deformed shape. And we can click this icon. Click Part Instances, click Concrete, make it remove. So in this case, we can now see the concrete. We can only see the stirrups and the main bars. We can check the displacement in either direction. We can also go to the View tab, ODB option, check the render profiles, so we can see the real profiles of the main bars and stirrups. If we want to see the concrete, select that icon again, make it back. So now we can see the concrete again. Now let's deal with the data to plot the load displacement curve. Click Create XY Data. ODB History Output. Continue. For the load, I'm gonna select all the RF2, which I built in the step module under the Create History Output. I select all. I use sum. I use the sum of all this reaction force as the fixed end reaction force. Give it a name, RF2. OK. And I also select the two nodes because I want to know the displacement. Here I use average because I want to use the average of these two nodes as the displacement. Give a name U2. Now click Create XY Data again, but this time we use Operate on XY Data. Let's find Combine. First, click U2. Second, click RF2. I want to make U2 as a positive value, so I add a negative sign. Save as. Let's make it load versus displacement. Click OK. Select it, plot. Alright, so this curve is the load displacement curve of the concrete column. If you don't want to make the plot within the Abaqus, we can also get the data out and use some other software to plot. So for instance, here we click Edit, select these two columns, Control C, start a new file like the Excel. Paste the data here. Make a new plot. We can also change the title, change the XY labels to make it look better. Alright, so in this short video, I have showed you how to use Abaqus to build and analyze a reinforced concrete column, how to deal with the data, how to do the post-processing, how to analyze the results. So if you have any questions, please feel free to ask me. And thank you for watching.